Hey, did you know that the dude who invented calculus wasn't even 26 years old? And according to Neil deGrasse Tyson, he did it on a dare. It's not even like he was really trying to. His friend just asked him a question and he kind of came up with differential calculus just to kind of answer the question. My question is, how does that happen? Remember that this dude didn't have a calculus textbook, he didn't have an AP review book, nor did he have a calculator. He didn't even have Sal Khan's video lectures. I know, crazy. But he didn't have any of those things. So how did he come up with differential and integral calculus? All he had was nature. So it must have been more base. So what we're going to do is we're going to scrap all the textbooks, we're going to scrap all the AP review books, and we're going to try to see it the way Newton saw it. Come on with me outside, I'll take you through it. Legend goes that Isaac Newton was walking along one day when he saw an apple fall from a tree. I've asked my younger brother to help me recreate this scene. And for a modern twist, I have my iPhone set up to capture video. Video, you'll recall, is really a series of pictures, literally frames that they used to have to cut and physically paste together in order to make a movie. Now before I show you the video, try to picture in your mind what a falling ball looks like. Because, and here's the big question, how fast is the ball going at the very instant that it makes contact with the ground? This is what the ball looks like at 6 frames per second. Now, I've already written down the height of the ball next to each frame that we see it in, and what you've probably already noticed is that the ball isn't traveling the same distance from frame to frame. It's getting faster. So what do we do to try and make sense of this? Well, we can make a table like this one, but that doesn't really tell us a whole lot. So if you're thinking that it might be a good idea to plot these points, you're right. It's a great idea because it helps us look at the problem from a different perspective that we can wrap our heads around. Because now look, the average speed is going to be the slope of the line between 2 points here. Rise over run here is change in distance over change in time, and that line between 2 points is called a secant line. So another way to think about this question of how fast the ball is going when it hits the ground is to think about the slope of a line at a single point. The slope of a line at a point like that is called the tangent line, or the line that is tangent to that particular point. This idea of a tangent line is really the crux of calculus. Here's what I mean. We can try to take the slope of the line between these 2 points, but it's just going to be the average speed between the 2 points, not the actual speed at the instant that we want it to be. We want something more like a speedometer on a car that can tell us the exact speed at any point in time. So here's what we do. We increase the frame rate. Look at this. When we increase the frame rate, the time between the frames is decreasing, so that when we get to 60 frames per second, the time between each frame is so small that we can basically ignore it and say that the change in height over the change in time between the 2 frames is basically the same as a single point in time. It's close enough. This idea that the 2 frames are so close to each other in time that they're basically the same point in time is called a limit, and it is very, very important in calculus. But that's the main idea behind it. Remember, these 2 frames that are so close to each other in time that they're basically the same point in time, and we call that a limit. I just wanted to give you a basic overview of the concept, and I hope you found this video very useful. In the next one, we'll actually start applying it with functions and more rigorously.